Hey guys, so in my last video, I covered Django, which is a Python-based framework. And in that app, we built a simple to-do app that demonstrated the fundamentals of Django. So I decided to take a step back for a second and cover the actual programming language known as Python, because I know many of you had some questions about Python in general, what it's used for, how do you write it in general, what is the syntax like. So in this video today, we're going to be doing a crash course in Python programming. So with that being said, let's get started. All right, folks, so we're going to start out with a couple of slides here, and I promise they'll be very brief. But before we delve into these, please make sure you hit that subscribe button and the bell icon and stay notified on future videos, because the more that you guys do this, the more videos I can bring you and hopefully help you guys understand more about various languages, frameworks, and libraries that's out there, and just kind of, build an overall community around it. So generally what we're going to be talking about today is the Python programming language. I'm going to give you guys a short overview of what Python programming is, as well as common uses of Python and several development tools that's used in the industry. So let's get started here with the overview. So basically what Python is a general purpose programming language, and it's used across many different platforms. Some of the most common uses I've seen in the industry is building web applications using frameworks such as Django and Flask, and building data science and analytics applications that's used to drive a lot of business decisions in various enterprises. But it's also being used in desktop applications, and I've even seen it used in mobile apps. So as you can see, Django really is a general purpose language. And the main reason why a lot of developers love learning Django and using it is because it's very simple to write the syntax compared to other programming languages such as JavaScript, Java, C#, and other languages. Now, there's a debate in the industry whether Python is an actual programming language or a scripting language. I don't really get into the specifics of that. I look at it as a language that can build applications, so it doesn't really matter if someone coins it as being a programming language and another dev coins it as being a scripting language. At the end of the day, it's used to build web applications, and that's what it is. And compared to languages such as C# and Java, Django is not necessarily strongly typed. So basically, you define your variables without specifying the data type up front. And then you can assign various values and then reassign values of a different data type to the variables. So it kind of closely resembles JavaScript in a sense, but it's written a lot more simply than JavaScript is. So one reason why I like using Python as a programming language is because of rapid development. It supports rapid development in all cases because many of the libraries that are out there that are built in Python allows developers to get started very quickly. Many of them contain several pieces such as authentication and authorization pieces and various other complex structures that's come out of the box that allow you to kind of get started very quickly with applications. And as of late, we've been seeing a lot of developments using Python within the AI industries. Python has a rich ecosystem that supports many applications no matter what platform it's being run on. And also the documentation out there is pretty hefty. You can find just about anything that you want to find in terms of documentation in Python forums or Python documentation hubs. So yeah, it's definitely well supported by the developer community. So kind of moving on here, there are some common uses. As I mentioned before, it's used in web applications. I've built a lot of web applications using Python Django specifically. Flask is a much simpler framework in a sense where it doesn't have as many bells and whistles as Django, but you can build web apps still very quickly. You just have to do a little bit more kind of like customized building around your web app. Now also Python is used in data science applications as well as analytics applications. So there are many different libraries that are being used within that space. That's not a space that I generally work within, but I've met developers who use it with libraries such as Plotly to build a lot of data science applications. And with that information, many companies can make smart business decisions. And Python is very reliable in the sense that any advanced calculations that have to be done on the back end can be done very quickly because of Python's reliable speeds. So yeah, generally it's very robust when handling complex calculations. And last but not least, as I mentioned, it's used in desktop GUI applications as well, and in a wide array of platforms ranging from mobile to web to desktop. All around, it's just a very, very robust programming language. All right, so generally there are many different IDEs or integrated development environments or code editors that Python developers use, but I love using Visual Studio Code because Python has been taken over by Microsoft in terms of them managing many of the libraries, but PyCharm is another common IDE that's being used out there in the industry. So it's definitely something that, it's very common to use. In this tutorial here, we're going to be using Visual Studio Code. So without further ado, let's go ahead and jump straight into VS Code and get started with our project. So you guys already know my style. Generally, what I like to do first is create a brand new directory to work out of. So let's go ahead and do that. I have my terminal open right now, and I'm in the directory where I want the new folder to be located. So I'm going to type in the command mkdir python crash. And I just want to also note that I'm on a Mac, but I believe this command should be the same on the Windows. So I'm going to hit enter here, and that's going to create my new directory. And now I'm going to change directory or CD directly into that. And now I'm going to type code dot and hit enter. Now the reason why that works is because I have Visual Studio Code installed. So if you guys don't have this installed, go online and install it. In fact, I'll add a link in the video description directly to the installation file for Visual Studio Code. It's completely free, no fees at all for you to pay. Now, also, I want to say that in order for your Python code to work, you need to ensure that you have the interpreter installed on your local machine. So you'll need to go to python.org and install Python. The latest version as of the time of this recording is Python 3. I'll also include that link below for you guys to go ahead and get started. I've shown that installation step in many of my videos, and it's very simple, so I don't think I have to show it here as well. But let's go ahead and get started with some of the coding. Once you guys get those packages installed, the very first thing we want to do here is open up our terminal. So I'm just going to click up top and say new terminal here. All right, and I'm going to go ahead and just clear this out. Now, what I want to do here to demonstrate the power of the Python programming language is I'm going to create a new file. So over here on the left, I have this sidebar that currently I have no files within because this is a brand new directory. I'm going to add a new file. I'm going to call this examples.py. Now, we want to make sure that this file is called, has the extension of .py because .py represents a Python file. So I'm going to go ahead and hit enter here. And that's going to create the brand new Python file for me. All right, so let's go ahead and kind of take it one by one, topic by topic here. So the first thing I'm going to do here is I'm going to create a function. And now what a function is basically a set of instructions that run at a given time. So based on an on-demand request, if you will. So we're going to create a function that contains basically a method that would allow us to print out text to the screen down below in our console window. So the reason why I'm going to do that is we're going to be working a lot with various outputs, and I just want to output things in a way that is easy for you guys to read and understand once you review this. The link to this code will be in the video description because it'll be in my GitHub repo. So if you guys want to go ahead and clone that repo and just kind of read through some of the examples, feel free to do so. All right, so first let's define this method. To define a brand new function, by the way, you guys will hear me say method and function interchangeably. It's essentially the same thing if some people prefer to say function over method or vice versa. To define a new function, we're going to use the def keyword. So I'm going to type def, and I'm going to create a function that would output something to the screen. So I'm just going to call this debug. And I'm going to use an opening and closing parentheses here. Now this function will take in two parameters or two arguments. The first one will be a tag parameter, and that's basically just going to be a string that's going to be sort of like a descriptor for us. And then the second one will be, let's call it output val, output underscore val. Now to end the signature line of a function, we use a colon. In other programming languages, you would use curly braces, but in Python, everything is based on tabs. or based on indentations. And I'll show you guys in a second what I mean. So just add a colon to the end of this line to symbolize that this is the end of the method or the function signature. So I'm going to hit enter. And if you guys notice, my cursor is now indented on the line number 2. This is because Python does not work based on curly braces. It defines its scope based on the indentations or a tab character, which is usually about 4 white spaces. So if for example, if I hit the backspace key, that brings me to the very beginning of line number 2. But I have an error message on line number 1 because I'm not indenting. So let me hit my tab, and you notice that squiggly line on line number 1 went away, but it's now on line number 2 because I haven't defined any behavior within this function yet. So let's go ahead and do this. What I want this function to do is just to simply print out the tag and then the output value. So I'm going to say print, and I'm going to use something known as an F string. So I'm going to type the letter F, and I'm going to put quotes here. Now I want to point out that you can use either single quotes here or double quotes. Python is very forgiving. The reason why that works in comparison to other programming languages is that Python doesn't necessarily define characters, right? So in other programming languages, you would typically use a single quote to specify, for example, like in C#, to specify a letter or a number character, just a single character. But in Python, you can actually define a string or a string of text within double quotes or single quotes. I typically love single quotes unless I'm going to use a single quote within the string itself, and then I may use double quotes in that circumstance. But for now, I'm just going to use a single quote here. And let's just say I want to output the tag that's being passed in, so I'm going to use curly braces to interpolate that value. So I'm going to say curly braces, and within that tag, and then I'm going to use a colon here, and then right after that, I'm going to have another set of curly braces still within the quotes, guys, and then I'm going to have output value here, or output val as the value. So what we're going to be doing is throughout this tutorial, we're going to be calling this function and passing in these 2 arguments to output that to the screen below. You guys will see how this works shortly. Okay, all right, so let's get started with some of the concepts here of Python. First, we're going to start with variables. So I'm just going to add a comment here. To add a comment, you just use a number sign or a pound sign. We're going to say variables and data types. Okay. So basically, as I said before, it's not a strongly typed language. So if, for example, in other programming languages, if you wanted to define a string, you would do something like string name is equal to, John, for example, right? And semicolon. But Python does not work this way. So in Python, we just define the variable. So let's just define a number variable. So I'm going to say x is equal to 5, right? So this is an integer, right? Because you can also have decimals like 5.0 or 5.2. But for this example, I'm just going to define a whole number, which will be 5. So x is equal to 5. Let's say that y is equal to 2.5. So here's a decimal here. Now, in other languages, you would also specify like an F character or something like that. But in Python, they made it nice and simple, hence its simplicity that I mentioned earlier, because we can just define a floating point number like this. We don't have to have any additional characters after the number itself. So I have the values of x and y. This means that these values are being assigned to this letter or this variable name to the left of the equal sign. That's all that's doing, right? Because, for example, if I were to output, and we're going to use our debug function, I'm going to call the debug function, and I'm going to pass it a tag. So let's just say value of x, and I'm just going to have a comma, and I'm going to pass in the variable x like that. Now, to run this code, I'm just going to come down here to my terminal, and I'm going to type in Python 3, because I'm on version 3 of Python, and then the name of the file. In this case, it's going to be examples.py. So if I hit enter, you guys will see that we see a value of 5 as it's being outputted right here. So the value of x is 5, and that's because we assigned 5 to the variable x. And then the same thing, if I were to copy this, come down here, paste it one more time, and change this to y, and then change this to y, and come back down here and run the same command, you guys will see it's also outputting 2.5 for the value of y. So that's basically variable assignment or value assignment to a variable. There are different names for it, but I generally say assigning a value to a variable. So that's how that works. Likewise, we can also assign a string. So we can say a name. For example, name is equal to Ron, right? And if I were to output that, let me just type the whole thing out, say debug. We're going to say name, and then we're going to pass in name. If I come down here again and I run this, you guys will see that it outputs my name, Ron. And if you guys notice, it ran pretty fast, right? Because again, Python is fairly fast when it comes to processing data. Okay, so now we've outputted the name. Let's add one more. I want to show you guys Boolean. So the first two were, the first value here, x, was an integer. The second one is a float or floating point number. The third one here, the name, is a string data type, and now the fourth one is going to be Boolean. So I'm just going to define a variable called is_student. I'm going to set that to true. Now, to work with Booleans in Python, generally, unlike other programming languages, you would capitalize the first letter of true or the first letter of false, right? To work, so it would be like something like this, right? You wouldn't type it out like this, like as you would see like in JavaScript and other languages, because if you notice, I have an error message when I do that. So, you know, in Python, make sure that the very first letter of true or false, so the T or the F respectively, is capitalized. So I'm just going to set that to true. And then again, I'm just going to output that. So I'm going to say, is this a student, for example? And then I'm going to pass in is student, like that. And now I'm going to come down here and run this code again. If you guys are wondering how I'm running this command so quickly, just hit the up arrow key. And when you hit the up arrow key, it'll output the previous command for you. All right, so if you guys can see here, it's outputting true, and that's because I set that Boolean value to true for that particular variable. So that's basically value assignment to variables. Within your application, it's a very common practice for you to use variables so that you can avoid code repetition. So that's generally how we would use them in any kind of application, no matter what platform we're using. All right, let's move on to the next topic here. So the next topic here will be basic operations. Just going to add a comment like that. So what do we mean by basic operations? So what we mean here is we have several different, and I guess I can call these math operations, all right? So let's say basic math operations. Computers are very good at calculating values. So generally, we can just give the computer several different values, and we can tell the computer to add, subtract, multiply, divide, find the remainder of a value after division. We can do many different things. So let me demonstrate this to you right now. Let's say if I want the sum of x and y. Now, you already know we defined x and y above, so we can still use those variable values. So I'm going to say sum is equal to x, and then I'm going to use the plus sign y. And let's output that and see what we get. So we're going to say debug. We're going to pass in sum as the string or the tag, and we're going to pass in the variable of sum as well. So if I come down here and I were to run this again, you guys can see it's outputting 7.5, and that's because 5 plus 2.5 is 7.5. So it's just that simple. We basically have a calculator at our disposal. So let's go ahead and try to subtract these numbers. I'm going to say diff for difference is equal to x minus y. And what I'm going to do here is I'm just going to come up here and copy line number 16 and paste that in here. And I'm going to change this tag to difference and this variable to diff. If I come down here, let's clear my console. If I were to run this command again, you guys will see now we're getting 2.5 because 2.5 subtracted from 5 leaves us with 2.5. All right. So now what happens if we multiply? You probably will guess it. It will be the correct answer. So I'm going to say product is equal to x. Now to symbolize multiplication, we use the asterisk character or the star character. So we're going to say x asterisk y. And let's output that same thing here. Let's just change this to product and this variable to product. All right, so if I come down here again and run the command, we see here that we're getting 12.5, which is correct because 5 multiplied by 2.5 is 12.5. And now let's work on division. So let's say we want to divide, that will be the quotient. So I'm going to say quotient is equal to x, and to symbolize division, you use a / character. So x / y. So let's go down here, output this statement again. We're going to say for the tag quotient, and for the variable, we're going to label that as quotient as well. Let's go ahead and output that, and you guys can see we're getting 2.0 here. And the reason why we're getting 2.0 and not just 2 is because we have the floating point or decimal number above that we're dividing by. We're dividing that 2.5 into 5, and that's why it's returning to us a decimal or floating point number. And I'll show you guys shortly how you can cast this. You know what? Let's go ahead and show you guys that right now. So let's say, for example, you don't want that to show as 2.0. Let's say you want that output to show up as 2 or just rather 2. Let me come down here. I'm just going to type in the comment typecasting. Let's say typecasting a floating point number, parentheses, decimal to integer, which is a whole number. Now to cast or convert an integer to a whole number, you would just use the applicable class name. So let me show you what I mean. Let's say, for example, we're going to say quotient. I'm going to define a new variable, quotient underscore as underscore int, for it's short for integer. That's going to be set equal to, and the class known as int, int. Let's open up parentheses, and now let's pass in our quotient like that. Now what this is going to do is it's going to take the quotient, which is currently 2.0, pass this into this class's constructor, which generally is basically what constructs this class object, and is going to convert 2.0 to 2. So let's see if I'm right. Let's go down here. I'm going to say debug. I'm going to say quotient as integer, and I'm going to pass in quotient as integer like that. Let's give that a shot. If I come down here and run this again, you guys will see that it's outputting 2 instead of 2.0. So the line above this is outputting 2.0. This is actually outputting 2 as a whole number. So that's basically how you convert a decimal to an integer. Now, one thing to be careful of when doing this is that if you actually have a value, let's say that the value is like 2.5 or 2.78 or whatever the case may be, if you convert this to an integer, it's basically going to chop off anything that's behind the decimal point. So only do this unless you're certain, 100% sure, that you want to truncate anything after the decimal point. Hopefully that makes sense to you guys. All right, so that's typecasting. Let me go back up above here. One thing I wanted to show you, I'm just going to put my cursor here on line number 24. I want to also show you guys how you get the remainder or the modulus result of a division operation. So let's say, for example, if I defined a new variable called remainder, and I set that equal to 13. Let's say if I want to get the remainder of the division, like the division result of 5 divided into 13. So you know that we're looking for a result of 3 because 5 goes into 10 2 times, and then we would have a remainder of 3. So to represent that in code here, we would just say 13 %5. And that's basically saying 13 modulus 5. And I expect this to return a result of 3. So let's go ahead and output this. So debug, I'm going to say remainder. I'm just going to put parentheses modulus. And now I'm going to pass in the remainder variable here to output this to the screen. Right? So let's go ahead and output that and see what we get. And as you guys can see, we get a result of 3. That's because we have 3 left over after dividing 5 into 13. So that's basic math operations. Very powerful. You can do a lot of complex mathematical equations. Hence why I'm saying that Python is often used in data science, because oftentimes you have to do a lot of heavy work there, working with various data types and working with various mathematical equations. All right, so I showed you guys how to typecast, a floating point number to an integer. But what I want to now delve a bit more deep into is typecasting a Boolean into a string. So let's say, for example, here, let me just add a comment, typecasting Boolean to string. Let's say, for example, I define a new Boolean here. Let's see, what do we want to call this? Let's call this one is student as string. So because above we have the is student variable, right? So we can use that again. So let's just say is student as str, and I'm going to set that equal to str, which is the class constructor, and I'm going to pass in this is student variable from above. And if you guys are not sure what I'm talking about, if you scroll back up, we have this is student variable up top here, right? So we're going to be using this is student variable instead of defining a new one, okay? So now I'm basically casting this Boolean to a string. But before I do that, let me show you guys something. Let me come back here, and above this line, I'm just going to output, again, the value. So I'm going to just say Boolean val. I'm just going to output the value of is student again, just so you guys can see something. Let me clear my console and output. So now if you notice here, we're outputting true, right? Because we set is student to true above. Is student is equal to true, as you guys can see here on line number 11, okay? So now that is a Boolean value. What I'm trying to do is I want to convert that value to text. I want to convert it to a string. And so what I'm going to do now is I'm going to output this value after it has been casted or converted to a string. So right down here, I'm going to say debug. I'm going to say casted to string, and I'm going to pass in is student as str. Okay. Now let's go ahead and run this and see what we get. So when I run this command again, you notice that I'm getting true still, but you can't really tell the difference between this output and the one above. You can't really tell whether it's truly a string or still a Boolean. So how can we determine what the data type is of this? Well, we can determine that by using the type function in Python. So let's go ahead and do that. I want to just check to see what is the data type of this. So let's just add a comma here, check data type. So to check the data type, we're going to say something like this. Let's debug. I'll just do this all in one line here. We're going to debug, check type is going to be our tag. And now we're going to pass in the type function. Make sure you have opening and closing parentheses because it's a function. And in this function, I'm going to pass in the is student as string, like that. And that should give us the type. It should output a class of str. All right, so let's go ahead and run this again. And as you folks can see, the very last output here, we have class str. So in fact, we are passing in a string. And just to kind of double check for sanity, let's go ahead and copy this. And I'm going to paste this one more time. And I'm going to check to see if the original variable, the is underscore student, is a Boolean. So let's go ahead and run this command python3 and then the name of the file, hit enter. And as you folks can see here now, it's outputting bool because it's a Boolean value. So this is a great way to check. You know, you can do something like this. For example, if you wanted to check if a particular, if a variable is a particular data type, you can say something like if, and then you can say if is student, for example, double equals, rather, sorry, let me correct that, if type is student, double equals, and then you can say like bool, right? If you wanted to do an if statement. We're going to get to if statements shortly, but if you wanted to check the type, the data type of something to see if it's a specific type, you would do it like this, all right? Let me just get rid of that so there's no confusion. Just wanted to show you guys that that's possible. All right, so this is how you check the data type, and you know, as you can see, this very important concept here. So just kind of make sure you become acclimated to working with various data types and variables, and so on. Let's get on to a little bit more complex stuff. The next thing I'm going to show you guys are control statements. So I'm just going to add triple double quotes here to open up a multi-line comment. I'm going to call this control, let's say control statements, that's fine. And then close it with 3 times double quotes. So this is a multi-line quote. You can actually have multiple lines of comments below this if you wanted to as well, like that, you know, if you wanted to add additional lines. I just want this one line, and I just wanted to kind of separate this into a different section so you guys know exactly what we're working on right now. Okay, so the first one I'm going to show you are if statements. So let me just do a number sign and say if statements. Now, what is an if statement? It's basically a way for us to control the flow of our application, and we check a set of conditionals within the if statement to determine if a particular condition evaluates to true or false. So first, what we're going to do here to demonstrate is let's create a new variable called age. For example, the age of a person. Let's set that equal to 20. The person's 20 years old. Okay. So what I want to do here is I'm going to have a block of code that's going to check the age of the person and then output whether the person is an adult or a minor. Or rather, you know what? Let's make it even more complex. Whether the person is an adult, a senior citizen, or a minor. So to do that, first we need the if keyword. So we're going to say if age is greater than or equal to 18 and colon at the end. So now just to kind of quickly go over this greater than sign, you guys know this from math class, means that we are thinking that age might be greater than 18, so like 19, 65, 100, or we're checking whether age is equal to 18. So this is how we write this. If I were to remove this equal sign, now we're only checking to see if age is greater than 18. But I want to check for both. That means I want to start at 18 and go all the way up. So if age is greater than or equal to 18, we're just going to output you are an adult. Okay? You are an adult. So that's what we're going to do here. Now, what I also want to do here is if the person is a minor, so with this particular block, we can assume that if the person is under the age of 18, they are a minor. So I'm just going to use a keyword called else. I'm going to say else colon. I'm just going to output here using the print function, you are a minor. All right. Now, I'm just going to keep things rather simple here, and then we're going to expand on this a bit. So, guys, what do you think the output of this is going to be? Are we going to output the first print statement or the second? So let's go ahead and run this and see what we get. Let's clear out the console and let's run python3 examples.py, hit enter. And what do we know here? We have you are an adult. And the reason why we have that is because the age is set to 20. Now what happens if I set age to 17, let's say, and save that? Let's go back and make sure you're saving between these. I should have said this earlier, but I'm actually hitting Command S to save. You can also use File Save if you prefer, but I'm using shortcuts to do that. So let's go ahead and run this again and see what our output is now. So after running this again, we see the output here is you are a minor, and that's because the age is equal to 17, which is below 18. And let's check 18 now. So we're right on the bound. So now let's set age is equal to 18. And let's see what we get. If I run this again, you see that we have here again, you are an adult. And that's because the age, we're checking if age is greater than or equal to 18. What happens if I remove this equal sign? Let's go ahead and remove that. And now we have this just if age is greater than 18. So if I run this command again, it's saying that we're a minor because again, it doesn't meet the condition. So it falls into this else block. So that's basically how these conditions work. Now, let's expand on this a little bit. Let's say, for example, if I wanted to also output whether someone is a senior citizen, we can absolutely do that. Let's check between ages 18 and 65, for example. So we're going to say here if age is greater than or equal to 18, and now we're going to use a keyword called and. And basically this and keyword is going to allow us to check both of these conditions. If either of these conditions are not true, then this check will automatically short circuit and default to the else block. So I'm going to say if age is greater than or equal to 18, or if the age is less than 65. Okay, so we're basically checking from ages 18 to 64. So this is going to output you are an adult if we fall within that range. If we don't fall within that range, we need to check for another condition. What if the person is 65 or older? We don't want to output you are a minor. So we need an additional block here to check for that. So the block is going to be called an else if block, or in Python, an elif block. So we're going to say elif, or elif. We're going to say if the age is greater than or equal to 65, then we're going to output print, and we're going to output you are a senior citizen. All right, just put some punctuation here. That's cool. Otherwise, we can assume if neither of these conditions above are true, we can assume that this is a minor, right? So we can just leave that as is. So now we have the age currently set to 18. Let's run this and see what we get. Let me just clear the console here. And let's go ahead and run this again and see what we get. So we see below, you are an adult again, right? Now, if I were to flip this to 65 years old, for example, what do you think the output will be now? So let's go ahead and run that again. And it's showing us you are a senior citizen. And the reason why is because we're checking if the age is greater than or equal to 65. Okay. If I were to flip this to 64 years old, so you got about one more year of work, it hit enter, it says you are an adult. All right, so this is powerful, as you guys can see. And to be quite honest, you'll be writing a lot of these conditional statements all throughout your logic. This is what determines what happens when a button is clicked, guys. So this is very powerful for you guys to understand this. All right, so let's go ahead and move on. Now, we also have something called the OR. Okay, we have the OR as well. So I'm going to show you guys another example with and OR. So let's just say down here. And guys, you want to make sure that you're tabbing correctly, just to kind of reiterate this, because again, Python is very unforgiving if you don't have the proper tabs in place. So make sure you have the proper indentation in place. In this case, I want to create a new function, so I want to make sure my cursor is at the very start of the line. And let's just say using and/or. All right, I'm going to give you guys another example. Let's say, for example, I want to define two Boolean variables. The first is going to be is sunny. So is the weather sunny? We're going to set that to true. And then the second one is weekend. Is this currently the weekend? We're going to set this to false. Okay. Now what I want to do here is if it is sunny and if it is the weekend, I basically want to output that we should go outside. So let's go ahead and do that part first. So if is sunny, and remember that's the and keyword again. If it is the weekend, we're going to say print. And here I'm going to use double quotes because I want to have the apostrophe here. So I'm going to say double quotes let's with apostrophe s. And again, if you don't do this, you're going to get an error message because then you would have to escape the apostrophe. So to avoid escaping, I could just use double quotes. So let's go outside because it's the weekend and it's a beautiful day and it's sunny outside, right? All right, so now what I want to do as a secondary case here is if that condition is not true, I want to basically output another output. For example, there's no work today if it is sunny or if it is the weekend. So if either of these are true, so let's say elif here, elif is sunny or is underscore weekend. So if either of these are true, then what I want to do is say print, and I'm going to say no work today, or let's say no work to do today. Awesome. Lastly, now I want to point this out, guys. I don't always need to have an else here. I can leave it as that. You don't always have to add an else here. But it's a good practice to have an else. as sort of like a catch-all. If something is never true, like if something will never be true, you have that catch-all, the else block here to catch this and to carry out a different set of instructions in your logic. So I'm just gonna have an else here, and let's say print I have to work today. So this is the case if it is not sunny, or it is not the weekend. So basically we're covering two different scenarios up top, which is if it is sunny and it's the weekend, we're going to go out. If it is sunny or it is the weekend, we're going to say we don't have to work today. And basically, otherwise, we're going to just say we have to work. We're going to assume that. So let's play around with this a little bit. I'm going to go ahead. Let's clear the console here just to see everything easily. Let's run this. And at the bottom, you guys will see it says no work to do today. And the reason why is because on this line here, so the first line is false, right? The first if statement is false because is sunny is true, as we've said it here, but is weekend is false. So the very first line will get skipped, and now it'll jump to this elif line. And basically, because is sunny is true, it's automatically going to short circuit and output this statement here, right? It's not even going to check if it is the weekend because we're using or. If we were using and here, then it would check for both as we're doing above. But in this case, we're using or, so it's just going to automatically short circuit because is sunny is true. If is sunny were false, let's do that right now. Let's change is sunny to false. So both of them are now false. If I go ahead and rerun this, you guys will see that the person has to go to work because the first two if statements are not true. The first one definitely not true. The second one also not true because both of them are not true. We're first checking is sunny, that's false. Okay, since we have an or, now we should also check if it is the weekend. So let's say, for example, if I go back up here and I leave is sunny as false, but I change is weekend to true, what do you guys think will happen? Let's go ahead and rerun this. And now it's telling me no work to do today. And the reason why is because is weekend is true. Even though is sunny is false, this or keyword is going to skip to this second condition. And because this is true, it's going to output this right here, right? Hopefully that makes sense, guys. And you can do many different things with this. For example, you can invert this. You can say if not, right? And that's the inverse of is sunny is true. So let's go back up here, for example. If I say if is sunny is true, up here, or rather is sunny is equal to true, but on line number 59, if I say if not is sunny, that basically means I think that is sunny should be false, right? So if it is not sunny and it is the weekend, do something. Let's just say that this may not make the most sense, but I just want to output this to show you guys what happens. So after outputting this, you see it says no work to do today. And again, it's because the first condition is basically not being met, because in this case is sunny is true, but I'm saying if not is sunny, right? Because I'm inverting it. So I would definitely say play around with this just to kind of understand how this works, because once you fully understand how Booleans work together with if statements, it's definitely a very powerful way to build applications. And it helps you to become a better developer because you're able to build more complex logic in that case, right? So let's go ahead and move on to more things here. All right, so we've covered quite a bit of the logical operators and math operators. Let's go ahead and cover some comparison operators. Now, we've already done this a little bit, but I just kind of want to delve a little bit deep so that way you guys can, fully understand what's going on. So I'm just going to say comparison operators here. And we'll keep this one nice and short since we've already done that. I'm going to say, I'm going to define a new variable, x is equal to 10 and y is equal to 5. Two new variables. Okay, so now I want to check x against y. I want to see if x is greater than y. So I can say if x is greater than y, what I'm going to do here is I'm going to print, and I'm going to use, again, the f string, because I want to output variables within this string. I'm going to pass in x here, and say is greater than, and then curly braces and pass in y. Okay, so now we're going to use an else statement, or rather, you know what? Let's use an elif. So else if x is less than y, colon, I'm going to print here f string, curly braces, x is less than, curly braces, y, else, if neither of these conditions are true, we can assume safely that both of them are equal. So we're going to say print, and we're just going to have a regular string here and say x is equal to y. All right, so let's go ahead and give that a shot, folks. And I'm just going to clear out the console here and run this again. And the first output we're getting here is 10 is greater than 5. And that's obviously true because 10 is greater than 5. So that means that we're hitting this first one right here, this first if statement. So let's go ahead now and let's change y to 11. You know what? Let's make it even more challenging. Let's change it to 10.1. Make it a floating point number, okay? So let's go ahead and run that again. And now it's saying 10 is less than 10.1, which is absolutely true because it is, right? So it's hitting this second statement, this elif statement right here. But what happens now if I set them both equal to each other? X is equal to 10 and y is equal to 10. Now it's saying x is equal to y, right? So that's also true. So it's hitting this else block. And again, this is why it's important to have this else block here, because if you didn't have it, then it would just stop at the very first two. And if neither of those were true, then nothing would be outputted to the screen. All right, hopefully that makes sense. All right, so that's pretty much on a high level comparison operators. There are other ones as well. So for example, if you wanted to, let's say for example, check if a value is greater than, I guess I can show you guys that. I did show it above, but let me show a different example. Let's say if I have a variable called z. Z is equal to 5 as well, okay? Now, if I want to check if z is greater than or equal to 5, I would do something like this. I'm going to set a new variable called is greater than or equal. I'm going to set that to z is greater than or equal to 5. And I'm going to just output here using the debug function that we've created. Let's pass in greater than or equal to, and we're going to pass in the variable we just defined, is greater than or equal. Okay, let's run that, and we see here that it's true because z is greater than or equal to 5. In this case, it's equal to 5, and I'm checking against 5 right here, so that statement is true. Okay, now if I were to change this to 6, for example, what do you think the output would be? It's still going to be true because z, which is currently 6, is greater than 5. Now, we can also use negative numbers in Python. Let's say if I say negative 20 or minus 20, this is a negative number now, right? So what's the output here? Yeah, so basically z is not greater than 5 because it's minus 20, so it outputs false in this case because minus 20 is not greater than 5. So this is basically how it's working here. Let me just set this back to 5. And now let's do another one. Let's create a new variable called is less than or equal. And we're going to set that to z is less than or equal to 5, like that, using the left angle bracket. All right, so let's go ahead and run this. Let's say debug. We're going to say less than or equal to. We're going to pass in the variable like that. And let's go ahead and run. And we see that this is true because it is less than or equal to. So now if I were to change z to 3, or let's say 2, for example, change it to 2 and run that again, it is still true because 2 is less than 5. But now if I changed it to 100, z is now 100, and we're checking against 5, it's false because 100 is not less than 5. So hopefully, this is like common sense to you folks. Just wanted to show you exactly how you would check for these conditions in Python. All right, so I'll set that back to 5. Let's see, what else do I want to show you? Let me show you is not equal to. So if I want to check if a value is not equal to another, I would do it like this. Let me just create a new variable called is_not equal. We're going to set that to z, and then we're going to use the exclamation mark like this, and then the equal sign, and let's say 5. Again, we're checking against 5. So z is not equal to 5. Let's output this. We're going to say debug not equal to, and then we're going to pass in is not equal. All right. So let's output that, and we see here it's false in this case because z is equal to 5. So it outputs false. But now if I came up here and I changed this z, let's say change it to like 5.5 instead, and if I ran this again, now it's true because 5.5 is not equal to 5. They're two different things. You know what? What happens? Here's a good question. What happens if I set this to 5.0? What happens? Because again, this is a floating point number and the other one is a whole number. What do you guys think will happen? So let's go ahead and run this. And you can see that it not equal to is false, right? Now, why is that the case? It is the case because it is not equal to each other. Rather, it is equal to each other, right? Because of the fact that just because this is a floating point number doesn't mean that 5 doesn't equal 5. 5 equals 5 regardless, right? It equals each other regardless of the circumstances. So this would still be the case. Now, let me show you something also. We can also check for equality, and I guess I should have shown you that first. Let me just come above the is not equal, and now line number 85, I'm going to say is equal, okay? And to check for equality, you would say if z double equal sign 5, for example, and let's output the debug is equal, so you guys can see what I'm saying here, is equal, and what I want to do, I want to pass in the is equal variable like that. Now, if I run this, you'll see the contrast here. So it is equal, even though it's 5.0, z is equal to 5.0, we are checking if it's equal to 5. Even though the 5 here looks like a whole number, 5.0 and 5 are the same number. So computers are smart enough to know that it doesn't matter if you put a decimal point in the value, it's still going to be equal as long as there's like a .0 after it, right? If it's like .01 or .00001, then it would not be equal, right? Because you would have that, you know, that decimal point afterwards, and then the precision would not be exact. All right, so that's pretty much how that works. Math operators and comparison operators and logical operators work together to create control flow within an application. Okay, so that's pretty much how that works. You know what? There is one more thing I want to show you folks here. I want to show you how to work with Booleans and inverting Boolean values. So again, let's come down here. Let's see where I want to show this. Let's come down here. We're just going to type in here, inverting Booleans. All right, so for this, let's say is teacher is equal to true, okay? Let's say, for example, at any given point in the application, I want to invert this value. So I basically want it to be false without actually resetting it to false like this, because in many different points of your application, you may not know if a value is false or true. So you may want to just invert it depending on what your logic is. A common scenario, for instance, is if you had toggle logic based on a button click, you may want to invert the value of the Boolean. So what I'm going to do here is I'm going to invert this. So I'm going to say here, I'm just going to reset is teacher. That's going to be equal to not is teacher. All right, like that. So that's going to invert whatever the current Boolean value is. So now let's output that. We're going to say debug inverted value or inverted Boolean value, and let's pass in the is teacher. What's the output going to be, folks? Pause the video to find out what the output's going to be. Let's run this, and as you guys can see, we have an output of false because we inverted it. Now we can also re-invert it again back to true. But again, the only time you would do something like this is if you have logic like a button click that does a toggle, or some other kind of switch-based logic that needs to be toggled on and off. Anything like that, you would then use this kind of inversion. All right, so let's move on from this. I think we've done enough when it comes to control flows and various operators. We're pretty much making some good headway here. Let's delve a bit deeper into some more complex topics. So let's talk about data structures. We just add a new comment here, say data structures. Now, in code, one thing I'll say is, in code, we want to follow a dry principle, D-R-Y, dry. Don't repeat yourself. Now, some people go against this and say, well, you should repeat yourself, but only twice, and you'll hear many different variations of this in computer programming. But as much as possible, you should try to avoid repeating yourself, especially if the code is exactly the same across the application, the global scope of the application. Now, the reason why I mention that is many programming languages, including Python, have created various data structures for dealing with groups of data or data that may be repetitious in nature. That combined with structures such as loops enable us to reduce the amount of code repetition we have in an application. So what I'm going to teach you guys right now are the various data structures in which we store data in memory in an application. So the very first one we're going to talk about are lists. So I'm just going to add a comment here. I'm going to say list. Now, what lists are ordered data structures. That means that the order in which we put an item within a list, an item of data, whether it's like an integer, a string, a Boolean, whatever the case is, an object, the order that we put it in will be the same exact order that it would remain in. So I'm going to just add some comments here and say lists are ordered, and they can contain duplicates. And what that means is that if I, let's say, have a list of integers and I have 1, 2, 3, I can actually add the number 1, the number 2, or 3 multiple times within the same list. So if you want to work with unique data, you need to make sure that there's a way for you to make the data distinct, right? And I'm going to show you guys exactly how to do that in Python shortly. So the other thing I want to point out here is that their contents can be modified. And what I mean by that is within the list, we can remove items from the list. We can add items. I'm not going to go too deep into the various functions of list. You can look up the information online by going to Python's website. They have some API documentation that talks about the various methods in Python. So you guys can do that on your own time because I don't want to make this video too long. All right, so let's go ahead and define a list. So I'm going to call this list my_list. And to define a list, it's basically like an array. In other programming languages, if you guys have experience with other languages, use square brackets to define a list. We don't call these arrays in Python, even though technically it is one. We call them lists. So just use the right terminology and you'll be fine. So let's define a list of integers. I'm going to just say 1, 2, 3, 4, 5. Nice and simple. Okay. Now, what I want to do is, let's say if I want to output the very first item of this list. Lists, just like arrays in other languages, are zero-based structures, which essentially means that the very first item of a list, in this case, the number 1, will not be in position 1. It would be in position 0 or index 0. Okay, so if you want to access the first item, you need to access the 0th index, not the first. So let me show you exactly how to do that. We're going to say debug first item in list. I'm just going to pass in here my list. And to get the first item, we need the square brackets again, and we're going to pass the number 0 like that. So let's see if that works. Let's go down here, run this command, and as you guys can see, it's outputting the number 1 because that's the first item in the list. So we're accessing the very first item. We can also get the last item of a list. Let me show you guys how to do that. Let's just make a comment here. Let's say last item of list. And down here, what I'm going to do is I'm just going to have a debug statement. I'm going to say last item in list. I'm going to pass in the my underscore list. And I'm going to just use the square brackets and say -1. So as you guys can see, you don't have to do like in other programming languages to get the last item in an array, for example, you would have to use the .length function or property and then subtract 1 from that to get the last item. But here you just pass in -1 and it will automatically know to go to the last item of the array. So let's just go ahead and check it to see if that works. So if I hit that, now you guys can see it's outputting 5 because that is the last item of the array, or of the list rather. So just to make sure that you guys understand, you can actually get the 0th of the first item using the 0th index, and you can get the last item using the -1 index. Now if you wanted to get the second to last item, you would just do -2. So let's try that. Let's go ahead and run that, and you can see we're getting back 4. So that's working perfectly. I would definitely say that, just be careful working with array indexes. One other thing I want to show you is you can actually get a range of items within the list. Okay, so for example, let me just show you that. Let's just say get range of items. Now I'm going to just define a new array here. I'm going to just say my names, and that's going to be equal to, we're going to put some names in here. Let's say Bob, comma, Jane. Let's put one more person. Say Billy, and comma, let's say Kim. Okay, let's put 4 people in there. Now, let's say, for example, I want to get every item in this list except Bob. I can do that like this. Let's say debug, get range as the tag, and I'm going to pass in my underscore names. And what I'm going to do is use the square brackets, and now I can say give me everything starting with the first index. So the second name, not the first, because again, we use the number 1 to specify the second item in the list. If we use 0, it would be the first. So here we want to start with Jane. So say give me everything from Jane all the way to the end. So to do that, we're going to say 1, and then we're going to use a colon after that. And we're just going to leave it like that. So if I go ahead and I run this now, you guys will see that it returns a new list starting with Jane. So a new list gets returned, starting with Jane, then followed by Billy, then followed by Kim. So it basically excludes, now we didn't remove Bob from the original list. We're just returning a brand new list, which is a range of these items. So you can see in Python, it's very easy to use array-like structures, which is the list. Very simple to use it. All right, so let's go on here, guys. So we've covered lists quite well here. Actually, there's another thing I want to cover here with lists before we move on. What I want to cover next is I want to cover how do you add an item to the list, right? That's also very important to do. So let's do that. Let's say let's go back up here to this list. Let's say, for example, if I want to add another item, I'm just going to say append an item to the list. So let's say my underscore list, and let's say if I want to append the number 6. So I'm going to say my underscore list dot append, and I'm going to append just the number 6. So let's go ahead and output that. We're going to say debug appended list, or appended item in list, and let's just output the entire item, my list. So let's go ahead and run that, and you can see above here that we have the number 6 on this line right here. So we've added the number 6 to the list, and you can do that with any kind of list, because a list can hold any kind of data, different types of data. In some programming languages, arrays or list in other languages can only hold data of the same type, but in Python you can hold any kind of data. So that's why I say Python is not strongly typed and it's very loose with its conventions. You can do many different things with it. Now, also the other thing I want to show you guys is what happens if we have a duplicate. So let me show you how to get rid of duplicates in list. Let me come all the way down here. I'm just going to say remove dupes from list. So let's say we have this list. Let's use the my list again. Let's just say my list dot append. Let's append the number 1, and we can just output that so you guys can see that it's there. We can just say updated list my underscore list. So that's going to show you the number 1 2 times, right? Should be at the beginning and at the end. Yep, it's right there. Okay. So now what I want to do is I want to remove that duplicate 1 from the list. I just want to show the number 1 once. So to remove duplicates, you just simply use the set function. And this can also apply to other data structures, which we'll cover in shortly. You basically use the set function to do this. So let's create a new variable called unique underscore list. We're going to set that equal to the set function, and we're going to just pass in here the my underscore list. Now, this is not it, guys, because what we need to do now is we're basically converting my list to a set. And a set basically is a data structure that does not allow duplicates. But because we want this to be outputted as a list, not a set, so that we can get access to other types of functions, we need to reconvert this back to a set. So what we're going to do first is list to set and then set back to list. So to do that, let's just wrap this set function with a list function like this. Let's just make sure we have parentheses at the end as well. And let's go ahead and output that, and let's see if we still have that duplicate 1 here. So I'm going to just say unique list and pass in the variable. So let's go ahead and run that and see what we get. So guys, if you can see here, we removed the duplicate. We have the number 1 once. So that's working perfectly. And this is exactly how you remove duplicates. So let's go ahead and let's continue. All right, that's it for list. Now, what I want to cover next are tuples. Now, some people say tuples, some people say tuples. I'm going to say tuples. Okay, so tuples are basically also ordered just like list, and they can also contain duplicates just like a list, but the main difference is that a tuple is immutable, which means that they cannot be modified. The contents within cannot be modified. So let me just add that comment here so you guys can reference that. So tuples are ordered and can contain duplicates. Their contents are immutable, or rather we can just say they being tuples are immutable, and their contents cannot be modified. Okay, so let's show you an example of what a tuple looks like. And a general use case for tuples is that you would use these if you want to ensure that none of the data within the tuple can be changed. So let's define a new tuple. We're going to call this my underscore tuple, like that. We're going to set that equal to parentheses, not square brackets, parentheses 1. We'll give a similar example, 2, 3, 4, 5, like that. All right. And I mean, that's pretty much it. You can work with tuples. Let's see what we get if we try to output the first item in the tuple. So I'm going to say debug first item in tuple. And I'm going to say here, I'm not sure what happened there, my underscore tuple. And I'm going to try to output the 0 with the index. What do you guys think is going to happen? Is it going to work? It works, right? Because again, these are sort of array-like structures in Python. So a tuple will work similarly to a list. The only major difference is the fact that a tuple cannot be modified. So that works. And what happens if I comment this, or rather copy this line, and come down here, paste this one more time, and this time, let's say if I want to get the second to last item in the tuple, I'm just going to use a -2 there. And let's just say here, second to last item in tuple. All right. Let's go ahead and run that. And as you can see, we're getting the number 4, which is the second to last album. Not album, second to last item in the tuple. All right. What I'm gonna do is, again, as I said, that tuples are immutable. They cannot be changed. So let's see what happens if I try to change a tuple. Let's see what happens. I'm curious. Let's say my underscore tuple. And let's say if I want to change the first item, I'm going to do a square brackets here, 0. And I'm going to set that equal to 100, like that. And let's try to output that and see what happens. Let's just call this changed tuple. And I'm going to pass in the my underscore tuple. And what I'm expecting, well, what the unexpected would be in this case is that we are able to edit this, but what I'm expecting is that this cannot be edited because they are immutable. So let's go ahead and run this. And as you guys can see, I'm getting a type error. And the reason why is because tuples cannot be edited, right? So, you know, the interpreter will let you know right away that you're not allowed to do this. So again, I would work with tuples if you don't want the data within to be changed. I will work with list otherwise. Right, I'm just going to go ahead and comment this out so you guys can know. Let's just add some comments. We could say you cannot edit the contents of a tuple. All right, I'm just going to go ahead and comment this out so we can get rid of this error message like that. All right. Now, again, what happens if we have duplicates? I'm going to just say remove dupes from tuple. All right, so we have this my tuple above. Let's go ahead. Let's just define another one. We're just going to say my underscore tuple 2, like that. And that's going to be equal to parentheses. Let's make this a Boolean. So we're going to say true, false, true, true, and false, like that. Okay, false. So this is a Boolean tuple. Now, we definitely have duplicates, and this is allowed, right? So let's just output that and make sure it is allowed. We're going to just say Boolean tuple, pass in my underscore tuple underscore 2, like that. All right, so let's go ahead and output this and see what happens. All right, so we see our tuple here. Everything works fine, no compiler issues, no runtime issues, everything works fine. That means that we have written legal syntax here. All right, but what I want to do now is I want to remove the duplicate Boolean values from this tuple so that the end result will just be true and false, just 2 items. So we're going to do that the same way we did it above with the list. Let's say unique underscore tuple, and that's going to be set equal to, let's do first set, and we're going to pass in here my underscore tuple 2. Okay. Now again, we need to convert this to the original data structure that we are targeting because we can't just leave it as set. So what we need to do is to cast this to a tuple. To do that, we're just going to wrap this within a tuple function like this with the closing parentheses at the end. And now let's go ahead and debug that and see what we get. We're going to say here unique tuple, and we're going to pass in the unique tuple value. All right, let's clear and run, and you guys can see that it's working perfectly. So those are tuples, guys. So let's move on to the next data structure here, and the next one's going to be dictionaries. So these are very powerful because a dictionary is a key value entry data structure. So essentially what happens is you would have unique keys that are mapped directly to values. Now the values can be duplicated within a dictionary, but essentially the keys will usually be unique. So let me just add a comment here and say dictionaries. Let's say dictionaries have key dash value pair entries where the key is a unique value and the value is or can be duplicated. Okay, let me just show you an example of how this works so that it can make sense. So the first thing I'm going to do is declare a new variable called my_dict, short for dictionary. And to declare a new dictionary, you use curly braces. So we're going to say curly braces here. And the first key here will be name. And I want to assign a name to this. I'm going to say Alice, comma, and let's assign an age. So we're going to say age. And here we can assign an integer value, just to say 25, like that. So right now what I've just done is I defined a dictionary with two entries, name and age, and I assigned values to both. Okay, so next what I want to do is let's just output this and see what this looks like. So we're going to say here, we're going to output, let's just say the name. So we're going to say name, and we're going to pass in the myDict, and to output just one of these values, we can pass in square brackets and then the actual key name. So we're going to pass in the key of name because that's what we called it here in the dictionary. So now this should output Alice. Let's go ahead also and copy this while we're at it and paste this one more time, and let's try to output the age of Alice. So we're going to say age, and here we're going to say age. All right. Let's go ahead and run that. And as you guys can see below, we're getting name Alice and age 25. So that's working. All right, so now let's see, what do I want to do next? Let's say if I wanted to add a new entry to the dictionary. So adding a new entry to the dictionary. So to add a new entry to the dictionary, it looks like this. We're going to say myDict, which is the variable, square brackets. Let's say if I want to add her location, let's say country. So we're going to say country, and that's going to be equal to, let's say, United States. And let's try to output that to see if we got that in. Let's just say updated dict, and we're going to pass in the myDict again. Let's just output the entire dictionary. So as you folks can see here, we are showing the country within the dictionary. So it's just that simple to add a value to a dictionary. So again, I would definitely look at the various methods. There are methods to remove items from the dictionary. There's many different methods for all of these data structures, especially for lists and dictionaries. For tuples, we're kind of limited because, again, you cannot really edit a tuple like that or modify its contents. But for the other ones, you can definitely do a lot of things. You can shift items around. There's many different ways. There's way too much to go over in this video, so definitely look at the Python documentation for some hints on how to do that. All right, excuse me, guys. So now let's move on here. Let's move away from this. Let's move on to loops. So I'm just going to create a new comment here called loops. Now, what are loops? Now, you probably have heard this at some point in programming. But again, as I mentioned before, we can be repeating code over and over again. So instead of copying and pasting your code in many different areas of your application, it may be a good idea for you to use loops. So that way you can reiterate and iterate and iterate over different blocks of code without the need of copying and pasting. It's a robust way of repeating code that's similar throughout the global context of your app. And it's definitely a way for you to follow the DRY principle, the don't repeat yourself principle. So what I'm going to show you guys here are essentially just two loops, for loop and while loop, which are the two main ones that you'll be using. So let's start with the for loop. Okay, so the way a for loop works is that a for loop generally would take in a specific, there are different types of for loops. And what I'm going to show you is more like a for in loop, where you can just kind of like loop through different objects. There's also one that has a range where you can loop over a series of lists, for example, different types of data structures, and you can have a counter to keep track of, what iteration of the loop. But I'm going to just show you the for loop that handles sort of like, it has like a temporary variable and then the main data collection being referenced. So let me show you what I mean. let's create, I think numbers are the easiest example I can show. Let's create another numbers list. I'm just going to put some random numbers in here. Let's say 100, 234, 490, that number, and then some crazy number. It's not making that crazy. Let's do this. Okay, just to switch it up a little bit. All right, so let's say, for example, I wanted to see all of these numbers and get each and every one by one from this list. Instead of me having to do, like, for example, earlier we were doing, like, you know, list name and then get the first one. Instead of me doing this and, you know, going down here and changing this to 1 to get the second item and so on, we can use a for loop to do this, or any kind of loop. I'm going to show you the for loop first. So we can say for number in numbers, which is this list above. What we want to do is just print out, actually we're going to debug. Let's do a debug, and we're just going to say for loop here so we know where this is coming from. We're just going to output the number. Now this number is basically a temporary variable. So this is the variable that is storing the value that's pulled from this list. So as this loop continues to cycle through each and every item, on the first iteration, number will be equal to 100. On the second one, it'll be equal to 234, then 490, then 8,342, and so on. Okay? So this number variable is very important because it only exists within the scope of this for loop. For example, you cannot come out here and then reference number out here because it's outside of the scope of this loop. All right? So you have to reference it within this loop because that's the scope that it's in, if that makes sense. All right, let's go ahead and output this and see what we get. So if I were to run this, oops, what happened? If I were to run this command here, you see that we're getting the output of all the numbers here in this for loop. Okay, so this is working. Now what else happens here is that within this for loop, you can combine it with like if statements. If you wanted to say, for example, let me just show you a quick example. Let's say if we said within this for loop, if number is greater than, let's say if number is greater than 100 and number is less than or equal to 491, for example, some random stuff. We're just going to say print. What do we want to print? This is a small number. Just for example, right? Maybe not the best example, but I want to show you that you guys can combine what we've learned so far with these for loops. So let's go ahead and output that and see what it is. So the output right here, let's save that. This if statement, oh, actually, you know what? Let's take this. Let's just move this below this debug statement and outside of the scope of that, okay? All right, so let's run this. And yep, we see it right here. This is a small number, right? So this is being outputted. Why? Because at some point on the first iteration, obviously this condition is false because 100 is basically less than this condition right here, because we're seeing if number is greater than 100. But on the second iteration, the number 234 would match this condition, right? It would match this condition. So then it's outputting what it needs to output here. So this is working. Then on the third iteration, because if you notice it outputs more than once, it's also true. So this is an example of what I mean with code repetition. Because if you were to copy and paste this, you probably may have to do it a million times, right, in an application. Versus using a loop, you don't have to do that a million times. You can do it once, and then as long as you have the correct condition set up here, or the evaluation set up, then you can absolutely reduce your code size and promote code reuse. So again, for loops are very, very powerful, and it's something that you have to master in any programming language. Okay, so let's move down here. And guys, on the GitHub repo for this code, it's going to be a much cleaner version of this code. I'm just kind of, making stuff up as I go along, but I'm going to have a cleaner version. It may look a little bit different than this, so don't count on this being the same. The best way for you to ensure that you have the same exact stuff that I have right now is to just follow along as you've been doing. All right, so the next one is going to be a while loop. Just type in here, while loop. Now, the main difference between a for loop and a while loop is that while loops generally depend on a counter variable. Now, a for loop can have a counter, as I said before, but I'm not going to go deep into that. You can look this up online. I want to just show exactly how for loops and while loops are being commonly used, not necessarily looking at the special cases. So to create a while loop, first I need to have a counter variable. So I'm just going to create a new variable called count, and I'm going to set that equal to 0. Now, the reason why we need a counter variable is that a while loop tends to loop endlessly until a condition is met, whereas the for loop above will continue looping until it gets to the very end of the list or the tuple or whatever data structure we're working with. Okay, so but in the case of a while, it could be that the loop will continue to loop infinitely unless we handle the condition appropriately. So let me show you how to do this. So let's say, for example, I want to loop until the count is equal to 5 or greater. We're going to use the while keyword to set up our loop. We're going to say while count is less than 5. So we want to start this with saying while count is less than 5, which is basically kind of like saying if count is less than 5, colon. And what we want to do here is let's just output while loop, and then we're going to pass in the count. Now, if we were to run this code just like this code will run for an eternity. We don't want to run this because this would cause an infinite loop situation, and eventually your computer may crash because it will be too much processing happening in the background. So what we need to do is we need to change this count variable so that eventually count will equal 5. Because if we don't do that, again, that means that this count is less than 5 will continue to be true because the value of count will never change. So that's why we need to change the value of count so that count will eventually be equal to or greater than 5. So to do that, under the code that we've written within this loop, at the very bottom of your while loops, you should always increment or decrement, depending on what you're doing, your counter. In this case, I want to add 1 to the counter. So I'm going to say count plus equals 1, like that. Now that means that on loop 0, count will be 0. Then it's going to loop back to the top, and then count will be 1 after this line gets executed. Count will be equal to 1, then eventually 2, then 3, then 4, then 5. And once it hits 5, then this condition up here will no longer be true, and the loop will be exited at that stage. So let's go ahead and run this and see what we get now. So I'm just going to run this down here, and look what we have. We have 0, 1, 2, 3, 4, but we don't have 5. And again, we're not outputting 5 because now once count is equal to 5, this condition becomes false, so it won't even execute the debug statement on line 160. So yep, this is working perfectly. And again, what do I commonly use? Well, I for the most part commonly use the for loop, right? Because in most cases, when you're working with enterprise applications, you're going to be looping through actual objects, not really just counter variables. So then I typically use the for loop, and the only time I use the while loop is if I'm really doing something where I don't really know how long something should loop for. It could be that it should be looping 200 times, 2 million times. I really don't know. So I might use a while loop in some sort of condition. It could be a counter variable. It could be some other kind of Boolean evaluated condition to determine when the loop should be exited. So just use the while loop with caution and just keep that in the back of your minds. Okay, excuse me. I think that's it for loops. And again, you can read up more on loops. There are other types of loops, but these are the more common ones. All right, so let's move on here. We're getting toward the end of this. Let's move on to functions and modules. Okay, So we've already been working with functions a bit. We've worked with the scroll all the way back to the top. We've worked with this function up here, this debug function that we've created. This is a customized function we've created. We've been dealing with the type function to check the type of a variable, the data type specifically. We've worked with the list function, the set function. We've already worked with functions, but let's delve a bit deeper into what functions are. Okay, so I'm going to add a comment here. I'm going to just say functions with no parameters. All right, so functions, as I mentioned, can take in a parameter or many, or you can have functions without parameters. Let's define one without one. Let's say, for example, I just want to say hello to the user. We're going to say def say underscore hello. And if you guys haven't noticed with Python, and I didn't mention this earlier, with Python, we generally use the underscore to separate words. This is a common convention in Python. I know you guys probably know in other languages you would say something like this, right? Like in JavaScript or in other C derivative languages. But in Python, the naming convention is usually first letter not capitalized or lowercase, and then underscore, and basically everything lowercase and separated by underscores. That's the Python convention. It follows more of a PHP style convention here. So, all right, we're just going to define a new function, call it say hello, and I just want to say hello to the user. So let's just do a simple hello world like that. Now, if I were to run this code right now, nothing will happen because we haven't called this function. So we need to send a call to this function in order for the code to run. Let me just show you what I mean. If I were to just run this now, we don't see any output from this function. So what we have to do is we have to call it. Let's call it by just naming, like mentioning its name. So say hello and opening and closing parentheses because we're not passing in any arguments for this. So let's go ahead and run this now and see what happens. So now you see that we're seeing hello world below right here. And that's only because we're calling the function that we've defined. And this is where the sheer power of object-oriented programming comes into play, because you can have functions across your application, whether global functions or class level functions, and you can repeat these calls over and over again instead of writing the same code 50 times, 100 times in your application. You just write it once and you can call it 50 times anywhere you want. You can call it within a loop, outside of a loop. You can call it within another class. You can call it within another file altogether. The possibilities are endless, and this is object-oriented programming, folks, at its best. All right, enough of the compliments here. Let's move on here. So, all right, we've already called the say hello function. Let's talk more about the next one, which is functions that have parameters. So let's define another function below. Let's just say, let's put some comments here. So functions with parameters. All right, so let's say, for example, I want to create a function called greet. So we're going to say def greet. And this function, I want it to take in two parameters, time underscore of underscore day and the name of someone. Now, what I want this function to do is I want the function, when called, to greet the person and address them based on the time of day it is. So whether it's morning, afternoon, or evening. So what I'm going to do here is I'm going to just have a simple print statement, but I'm going to use an F string. So I'm going to type the letter F and open up my single quotes here. And now I'm going to say good, curly braces, and I'm going to pass in time of day here, and then space, and then curly braces again, and pass in the name, and then put an exclamation mark here. Now again, if I were to run this, nothing will happen because we haven't called the function yet. So let's go ahead and call the function. All we need to do is call greet, and let's pass in morning, and let's pass in Brad. Now, one thing I want to say really quickly here, though, is, you know what? I'm passing in morning as all lowercase. Let's capitalize this. So instead of manually having the user capitalize the first letter, let's just use the capitalize function, which is built into Python. So we're going to say time of day dot capitalize and opening closing parentheses like that. So that's going to make the M in morning capitalized. So let's save that and let's run this. And you see below we have good morning Brad. Okay, now let me just copy this 2 more times. So on the second line, I'm going to say good afternoon, Becky. And then I'm going to say good evening, Tommy. All right. So let's run this, and now we get 3 greetings, folks, and it's capitalized appropriately. And all we're doing is we've set up the behavior, because that's all a function is. It's just defining the behavior of a particular object or module or whatever have you. And all we're doing is passing in 2 arguments that are being taken in as 2 parameters to this function, time of day and name, and passing those in. We are then passing this in to the string through string interpolation and outputting this to the console. So this is working, and this is how you use functions. Hopefully that makes sense. And I want you guys for homework to practice working with functions. Maybe define functions that add the numbers together, subtract, multiply, divide, and output that to the screen to see what happens. The more that you write functions, the more you start to understand. All right. All right, so let's see, what else do we want to work on? Let's work on modules. So those are functions. Let's talk about modules. Now, Python, as well as any Python framework or library you'll work with, often, in many cases, work with modules. And modules are essentially libraries that are within the Python framework, as well as libraries that are Python dependent. So a module can be used to carry out certain types of functions. In this case, let's say if I want to bring in the math function, I can import, with the import keyword, I can import the math function, which is a built-in, not a function, but rather a module within the Python framework. So I'm bringing in this import math module. And let's say, for example, if I want to get the square root of a number, let's say the square root of 25. So we know that that should be 5, because 5 times 5 is 25, so that would be the square root. So let's output that to see if that's true. We're going to say square root, and what we want to do here is we want to get the square root. So to get that, we're going to call math.sqrt for square root, open parentheses, and let's pass in the number 25, okay? So this is going to give us the square root. Let's go ahead and run this. And as you folks can see, it's returning 5.0 or 5.0, which is basically 5. Okay, we can then cast it if we wanted to an integer, but I'm not gonna do that right now because it's returning the correct result. So as you can see, all we had to do here is just import the math module, and then it gave us access to math functions within this module. So there are plenty of math functions, like if you wanted to also get, other types of, equations, or rather calculations done in Python, you can import these other functions that's a part of the math module, and it'll give you access to a lot of mathematically based functions. So definitely look into the documentation for that. I'll link it below. All right, let's move on to classes. This is the bread and butter of object-oriented programming, because a class is a blueprint of an object. So, for example, if we were to have a dog class, so let's define that. We define a class by using the class keyword. So let's say class dog. Now, basically what I'm doing is I'm setting up my application to say anytime I create a dog object, I want to use this template to pretty much set up the state and behavior of a dog. What does a dog do? So on and so on. So let me just add a quick comment below here. I'm just going to say create class here so you guys know exactly what that's doing. All right, so what we want to do first is we're going to create a class called dog. This is going to be a dog object. And essentially first what we want to do is we want to initialize some of the properties that this object needs to use. So what we're going to do is we're going to define a constructor. Let's call this constructor here. And to define a constructor is basically a special type of function in Python that we can use to set up our initial configuration of an object. So we're going to say def underscore underscore init underscore underscore parentheses, init standing for initialize. And let's go ahead and pass in some of the arguments that we need. The first one we need is self. So this self parameter represents the class that is in. So self represents the dog object in itself. The second argument we're going to be passing into this constructor is called name. And then the third is age. We've been working with that quite a bit today, so let's continue that. And let's add a colon at the end to signify the ending of this and hit enter. So now what we want to do here, and this is a common thing that's done in many programming languages, and Python included, is whatever we pass into this constructor, the name and age in this case, we want to reassign those values to the self's property. So we're going to say self.name is equal to name, and we're going to say self.age is equal to age. And what that's basically doing is taking in the values that's being passed from somewhere else. Could be like an external file, external module, and so on. And we're basically assigning those values to the properties that's a part of self, the attributes that's a part of the self object, which is, in this case, a dog. So in other languages, just to kind of clarify, normally you would come up to the top of the file and then you would have like a name variable. You would set that to like an empty string, and you would have an age, and you might set that to null or none. For Python, null is none, folks. I haven't described that or explained that yet. You don't use nulls in Python, you use none, okay? So in other programming languages, you would do this, but in Python, you don't have to do it like this. You can if you want. It would still work, but you don't have to. You can just say self.name and self.age, and that will take care of the rest. So again, Python, very, very concise programming language. That's why I love it. All right, so what I want to do is I want to define a special method here. I'm going to define a method that will allow the dog to bark. So I'm going to say def bark, and I'm going to pass in here just self, because really when I call this method, I'm not going to be passing any arguments. In Python, you must always pass self as the first parameter, always. And even if the function doesn't take any arguments or parameters, you still have to pass in self, because that's how Python knows that it's related to this class. That's just the way that it compiles compiles the code. So let's just go ahead and output here woof woof. Okay, so when I call this bark method, I want the dog to bark. So now let's go ahead, let's imagine we're in a different file, and let's say we want to use this class. So to use this class, you would basically instantiate a new dog object like this. You're going to say my underscore dog is equal to dog. Now, if you were in a different class, normally you would have to import dog. Okay, but in this case, since it's in the same class, we don't have to do it. Okay, so we're going to say dog, and we're going to pass in, we don't pass in self, because remember, self is always the parameter. If you look at the init constructor above, self is usually the first parameter, but we're going to ignore this parameter here, this argument, when we're actually calling the function. We're going to ignore the self, because that's just for Python to know what it relates to. So we're just going to pass in here the name, which is Buddy, and the age, which is 3, so 3 years old. And now what we want to do is let's do two outputs. The first output, I'm just going to output the dog name, just to show you guys that we can access these values from outside, and we can get the dog name by saying my underscore dog dot name. And then the second thing I want to output here is the let's output the in fact, we don't need the debug here. Let's just go ahead and output let's call the method, the bark method, to output woof woof. So to do that, we're going to say my underscore dog dot bark, my underscore dog dot bark, in parentheses. And again, we're not passing any arguments, even though We have a self here, and that's because for self we don't pass in arguments. Okay, let's test. Let's run this. So I'm seeing the output of Buddy as a name and woof woof. So that's working perfectly. So this is how you work with functions, guys, and classes. Classes are definitely important because your whole application can have many classes. It can have dozens, hundreds, thousands of classes, right? And a really big application can have tens of thousands of classes. So it's important to memorize exactly how we did this and eventually make it second nature by practicing. Okay. All right. So what do I want? Okay, let's talk about files. Let's do file handling next. Now in Python, you have a very sleek way of working with files, creating files, writing text to a file. Um, you know, as I said, reading files and editing files is a really robust way to do this. So let me show you some examples. First, I'm just going to define a file name variable. I'm going to set that equal to example.txt, right? Because this is going to be the file that we'll be creating and eventually reading from and editing. Now we can use Python code to create a brand new file. So let's come down here. I'm just going to say here, writing to a file. So what I want to do is I want to write to a brand new file. Now, other programming languages like Java, which is very common for writing to a file, it has many different types of buffer classes to write to a file, reading from a file, and so on. Normally, you would have to create the file in older versions of Java, but in Python, it makes this very simple. You just simply say file, just define a file variable, and then there is a function that's built into Python called open. And so for the open function, I'm going to pass the file name we just defined because I want to be able to create and write to a file called example.txt, and this file will be put in the current directory, which is the root directory. So we're going to say file name, comma, and let's pass the W. So we're going to say a string of W. That means write. So write only, basically. All right, so let's, or in this case, just only write to this file within this function call. That's what that means. So we're going to say file.write. This is the function. And what we're going to do is just give it some text. So let's just say here, this is a text file. And then finally, just like we would do in any other programming language, we would have to close our stream. So we have to close the file in itself. We're going to say file.close. And that's it. So there isn't really anything to output here because what we're going to do is we're going to run this code and we're going to check to see if this file has been created, as well as just to check to see if the contents are within the file. So let's run this. And here on the left in the sidebar, we see now an example.txt. So if I open this, now you guys can see we have the output above. We have this is a text file being outputted on line number 1. So this is working. All right, let's go back here. Now let's say, for example, if we don't want to read the contents directly from the file like we just did. Let's say if we want to use code to get the contents. There are multiple ways of doing this. The first way I'm going to show you here is to output the entire contents. So I'm going to say reading entire file contents. All right. So to read, we're going to use the with keyword to read from a file, because the reason why we need the with is because we need to be able to handle this request is sort of like in an asynchronous fashion. So we're going to say with open, and we're going to be passing in here file name. And let's see here, what do we want to do? Let's add the second argument here. We're going to pass in the R keyword here, and that means read. So the first one was W, which was write, and this one is read. And we're going to say as file. So we basically want to then store the outputs of that as to the file variable. And on the next line here, we're just going to grab the content. So content is equal to file.read. Okay, and now we're going to output the contents here. In fact, you know what? Let's use our debug function. Let's say debug, comma, and let's just say file contents like that. All right, so let's run this and see. Now you guys can see down below we're getting our file contents. So basically the text that's in the file is being outputted to the console now. So if you had a lot of text, it would be outputting all of that text to the console. So using this function, the reason why we need the with keyword is because we'll be reading quite a bit of text in some cases, and we need to be able to asynchronously handle this response instead of just kind of like waiting for everything to process. So using the with will just kind of bring in the resource and then assigning that to the temporary variable. And then we're able to execute the read function on the file contents to output that to the console. All right. So now the other way to do this is we can read line by line. So let me just go back to our file here. Let's see here. Let's open up our file. I'm just going to add some text here. Let's add some lorem ipsum. Can I do that here? No, I can't. Let's just add some gibberish. You can just add any type of gibberish. Let's put them on different lines like this. All right, and save that. Now let's go back to our .py file here. I'm gonna rerun this just to see what we get. Let's just rerun what we already have. I think we actually have to, let's try this. There we go. All right, so it looks like it's not outputting. Let me just double check here. Did I save that? Okay, yeah, I think I know the reason why. It's because we reran the code. Let's go back to the .py file. I'm just gonna put it in here. Let's just put some gibberish in here. Let's go back up here. I just wanna put some more. I'm gonna put a new line character. To put a new line, like to create a new line, you just use a \n. Just put some gibberish here. I'm going to do another \n, and I'm just going to copy this so I can have multiple lines. I'm just going to copy this all the way to, you guys don't have to do this if you don't want to. I'm just doing this so that it's clear, everything is clear. Okay, like that. Do it several times. I think that's enough. Okay, I did it about 4 more times. Excuse me. So now if I run this again, we should get, yeah, see now we're getting this new input here, or output rather, and they're on different lines. Now the reason why I did that is I want to show you guys how to read line by line. So let's do that. Let's create, say, read file contents line by line. Okay, so excuse me, to read line by line, what we have to do is something similar. We're going to use the with keyword, and we're going to then use a for loop, if you guys recall what that is, to output line by line to the console. Let's try it. Let's see if this is going to work. So we're going to say with, open file name, and I think we need to just pass in the same R. Let's try that. We're going to say as file again. And this time we're going to say for line in file. All right, because this file is essentially like a list of lines. So that's the reason why we can do this. Okay, and then we're just going to, let's just do a regular print, and we're going to print out line dot strip. This strip here will remove any extra lines. And you know what, just to test this out, let me come back up here to this line up here where I added the additional text. I'm just going to add another \n right here. This is another new line character. So what I'm expecting to happen is when I run this code will strip out this last new line character as well as the other ones before that. All right. Okay, so let's give this a shot. Let me clear this so you guys can see, and let me run this. Now, what you're seeing here is that the new line character did get stripped out. All right, everything got stripped out and I'm reading line by line. In fact, what I'm going to do is let me run it one more time. But before I do that, let's convert this print to a debug so we can add a tag real quick. So let's say line like that so you guys can see what's happening. So let's rerun it. And now you guys can see I'm outputting line by line because we have this line prefix or this tag being outputted first, and then I'm outputting every line by line. But of the output above, you notice we don't see anything like that. That's because we're outputting the entire file's contents. Okay, so this is basically how you output line by line. And if there's a specific line where you're looking for a certain piece of text, then you would use like functions to check. Like, for example, you may use like a regex expression to check for a specific series of characters within a line. And this is where it's getting to text parsing. So you can create some really powerful apps using some of this logic here. All right, so what happens if I want to edit an existing file within my code? Let's say if I want to append some text. So let's try that. Let's say appending to a file, right? So to append text, again, we're going to use the with open file name, and I'm just typing this all out again. I could have copied it, but I'm typing it again because it helps to cement this in your brain. So the second parameter this time will be an A for append as file. Okay, so what we want to do here is we're going to say file.write again, right? Did I type that correctly? File.write. Okay, and now what we want to do here is just add the text. Now, before we add the text, we want to just add a new line. So we're going to say new line character \n, because remember the new lines got stripped. When we call the line.strip, that gets stripped, or any new line will get stripped when we're basically reading and trying to append. So what we need to do is add this new line character first, and then we can say, for example, this text is appended to the file. This text is appended to the file. Yep. All right, let's go ahead and run this and see what happens. So what I'm going to do is I'm going to run this, and then I'm going to go directly to the file to see if any change has been made, because we're not going to see it because this code is running at the end. So let's go ahead and run it. We're not going to see this in the console, but if I go to the .txt file, you can see right here that we see the text. So it definitely appended it, and it added a new line to it. And the reason why there's a double new line here is because at the end of this new line, remember, we didn't call .strip actually. So let me go back here and show you guys what I mean. What's going on here? Here we go. So in the example above, we called the .strip function to remove the new line. But here, we're not doing that, right? We're not doing that here because we're not working with the line directly. So there is a new line at the very end, as you can see up here. If I go to the end, right here, we have a new line. So we have this new line, which is going to be the first line break. And then I have another new line, which is going to cause an empty new line above the output. So that's the reason why it looks like that. So yep, this is working. Perfect. So now you guys know how to read and write and edit files using Python. Awesome. We are almost at the end. The last thing I want to show you guys are exception handling techniques. So let's go to that now. Let's create a new, and part of this is going to be related to file handling. So exception handling. Okay, so what is exception handling? So basically our application at any given point can run into errors. Unexpected behavior, error messages, anything. We need to be able to handle those scenarios gracefully, right? Because if something crashes, let's say you're working on a team and it's a Saturday and something crashes at 11 p.m. on a Saturday, you definitely don't want to have to go into work, especially if you're on call. So using exception handling techniques can help reduce the chances of errors occurring. Now, let me show you a common example. Let's say, for example, we're working with this file, right? Let's imagine we're trying to read a file, but the file does not exist. All right, so let's say handle exception where the file may not exist. So generally what you would do as a precaution is you would write any code where you think it could fail within a try except block. So we're going to say try, and then we're just going to say except for now, like that. We're going to come back and edit the except block soon. Let's just do the try block for now. So let's write the code to to read from a file again. We're going to say with open. This file name, let's give a fake file name, one that does not exist. We're going to say file does not exist .txt, comma, and we're going to pass in the W, or rather the R, to read from this file as file. And then we're going to say content is equal to file.read. And then we're going to just print content like that. All right. Now, on a good day, this code should run and not cause any errors, but we do not have a file called file does not exist .txt. We don't have that file, and if we run this code, an error message would happen because we're not writing to this file. We're trying to read from a file that does not exist. So we need to be able to handle this exception in a special way, right, to handle it gracefully. Now, the type of exception that would get thrown in this case will be called a file not found error. So file not found error. And you can find out more about these error types online. Just look up exception handling Python. It's going to give you a list of all the various exception classes, because essentially that's all this is. This is a class. This is a class called file not found error, which inherits from the exception classes of the Python framework. All right, so what I want to do here is if the file's not found, I just want to output this to the console. So file not found. That's it. Now, you may be asking, well, this is, redundant. Why are you doing this? This is redundant for you to do. It's not redundant, folks. And the reason why is if I didn't do this, the program would stop executing as soon as the error is encountered. So we avoid the crash by handling this in a try except block and then just outputting a message to the screen. Now, in a real world scenario, you would output something to a log file or to a database table to capture this error message so that your developers can troubleshoot and triage this particular error. But in this case, what we're just going to do is just output this to the console to keep things nice and simple. So let's go ahead and run this and see what we get. If I run this, you'll see that we're getting file not found, and that's because the file does not exist, right? Now, as a rule of thumb, even going back to the code that we've written above, all the code, generally, I would try to look for areas where I can use the try except block. So for example, we can also use, let me just double check. I think we can just use an error, right? Not end of file error. There's many different types of errors we can use. We can just use the except, I believe. So we just say except and we don't specify. Let me just clear our console. If I ran this, you guys will see that we are still getting the error message, file not found. We're still getting it even though I didn't specify the file not found error, because what happens is if you don't specify the class, the error class, the except block will then use the base exception class available to you via Python, which is just error, just the error class. And then it will still output and handle this gracefully. So rule of thumb and my word of advice, if you know what kind of error will be thrown from a particular block of code, I would definitely specify it here. I would say except in this case, file not found error, just to be concise. If you're not sure, you can just have except and then colon to kind of like have a catch-all if you're not 100% sure. All right, but the best practice is to use the specific error class name here. All right, let me give you guys one more example. There's a common phenomena in the, or rather phenomenon in computer programming called divide by zero. So a divide by zero exceptions. Let's just say handle divide by zero exception. Now this exception occurs when you're trying to divide any number by zero, right? Now naturally in mathematics, if you divide, let's say 10 by zero, then the answer would be zero. But in computer programming, many languages would error out when you run this calculation to avoid any kind of data conflicts, right? So what we need to do is we need to gracefully handle this situation. So let's first write here the try except block. We're going to say try, we're going to say except. And again, we have the choice of either going with the base here by just saying except, or we can be more specific. If we want to be more specific, we want to handle the zero divide or the zero division error. I think it's called zero division, not divide. Yes, zero division error. So what that is going to do is that if we divide by zero at any time within this application, then it's going to error out any message that we specify below. So let's handle the try first. Let's set up the error scenarios. We're just going to say result is equal to 10 divided by 0. Just that simple, right? So that's going to cause an exception. So let's print out here, you cannot divide. Actually, let me not say you cannot divide by 0. Let's say, yeah, you know what? Let's just say cannot divide by 0. Let's say that. Cannot divide by 0. You technically can divide by 0, but you know, when you're working with code like this, generally what I would do is if you think one of these operands would be 0, I would just set your variable to 0 explicitly. All right, cool. Or maybe have like an if statement that if any one of these operands are equal to 0, then just do some other type of logic. All right, let's run this and see what we get, folks. Run, and we get the error message. We get the cannot divide by 0 message, and that's because we're trying to divide by 0 and instead it's throwing an exception and it's basically not allowing us. Now let me just do one more thing to show you guys something. Let's write the same code down here. Let's say result again is equal to, let's say 24 divided by 0, and let's then print out the result. And I'm going to show you guys what's going to happen. Just run this and you see we're getting the exception now, right? So this is what an exception looks like, folks. The exception here is saying 0 division error, right? So which would you rather have on your screen? If you're an end user, would you rather have cannot divide by 0, or would you rather have something like this gibberish here? Because this is essentially what it is, right? It's gibberish. You don't know, like the average end user would not know what this is. A developer may, but the end user would not know what this is. So that's why it's important for you guys to kind of adhere to this and try to use best practices and employ try except blocks wherever you can. And the same exact concepts exist in other programming languages. So whatever you learn in Python is directly transferable to other languages. Maybe the syntax and the keywords change, but essentially it's the same idea. So I mean, guys, I think that's pretty much it. I've shown you everything you needed to know in terms of the fundamentals of the Python programming language. I would advise you guys to look at my Django programming course. It's the Django Crash Course, which is on my channel. It's going to show you guys how to create websites or web apps using Python and Django. So give that one a look next. Make sure you hit the like button for this video if this was very helpful to you. If you've learned something, leave a comment below. Subscribe to this channel, hit the bell icon. Don't forget, because I'm coming back with more videos, guys. Make sure you show me some love. Happy coding, guys. Until next time.